Okay, good morning. Welcome to
Math number 1026.
Math 1026. We're actually today going to do a project that I think we did a long time ago, comparing Earth and Mars and their orbits. So I looked up on Wikipedia that the Earth is 93 million miles away from the Sun, approximately.
Okay.
And it takes approximately 365 days to go around the Sun, and Mars is 142 million miles away, and it takes about 687 days. So what are some things you know about the orbits of Earth and Mars, or anything you might think would be interesting to talk about?
Well, are we assuming... Well, I know the distance varies at some point. Some points it gets closer and farther away.
Yeah, that's a very good point. The orbits are actually ellipses, not circles. For purposes of this talk, we're just going to pretend they're circles, but that is an extremely important point. They're not circles.
Okay. Well, their orbits are all in a plane, or sort of lined up in a plane.
Oh, very good. Yeah, it's very interesting how that happens, that the orbits are in a plane instead of sort of scattered all over the place. Because you might imagine that maybe one planet could be circling this way and another one could be circling this way. Or even that one planet could be circling this way and one planet could be circling the other way.
Yeah.
But that's just not how it happens. Mostly, anyway. Do you know anything about these orbits or any kind of fun facts?
I mean, not really. Mars is roughly double Earth's orbit, but it's not twice as far away. That's probably because Mars is smaller.
Oh, you mean
The length is about double.
They probably move at different speeds.
Mm-hmm.
They might for them.
I'm actually really glad you mentioned that, because one of the things that got discovered by Kepler, I think, it's at least named after Kepler, about orbits, is that for planets, or maybe for anything, r cubed over t squared is constant. So we could actually check this out.
So the radius of the orbit.
Yeah.
Divided by the time it takes.
Yeah, so we could just use, because we can just, it doesn't matter what units we use, so we could say 93 times 93 times 93 divided by 365 times 365 for the Earth. I don't know. So for the Earth we get about 6.037. Okay, and why don't you do Mars?
7 times 6, 7, 8. Oh no, that's the.
You can just hit clear, or all clear. You probably need to do. Yeah.
2. .06. So.
About 6.067. So pretty close.
Mm-hmm.
Especially since we were making some small approximations here. Yeah, you can see we get pretty close. So your observation actually is a law of physics. Basically it says if you know 3 of these 4 numbers,
you know the other one.
You know the other one. So if I know that the Earth is 93 and 365 and I know Mars is 142 million miles away,
you can figure out that it's 67.
Yeah, so you thought it might have to do with the fact that Mars is smaller. But actually, the size of Mars doesn't matter. This law would, once we know the Earth's orbit, we'll know what this constant is for Jupiter, or Saturn, or anything.
Mm-hmm. So we actually could use this to figure out the speeds of the planets. We could calculate the speed at which they're orbiting.
Yeah, that's another great point. And the interesting thing is there's a law that even tells you about the speed, and it uses the fact that they're moving in ellipses. So if I draw an ellipse, I'll put the sun here so it's clear that we're in an ellipse. That law, which is another one of Kepler's laws, says that you sweep out equal areas in equal time. So the time here and the time for the same area here is the same.
Neat.
Yeah, so there's a lot of really interesting math that goes in, or I shouldn't say that goes in, that comes out of studying planets. There's a lot of there's actually, Kepler has 3 laws and we've stumbled onto 2 of them. But I'm going to show you something really neat about the orbit of Mars and Earth. And we saw it from our friend Dylan Berger. Or I saw it yesterday, something he showed, which is really cool. And then we're going to come back and look at the polar coordinate representation of these orbits.
Cool.
All right?